Hi, my name is AYSYA binti ROSIDI and my metric number is 307137. So today I will explain about how we measure if a computer program is good or not. In computer science, we look for something called algorithm. A good algorithm is usually measured by 4 things: efficiency, simplicity, generality, and optimality. Efficiency means how fast the program runs and how much memory it uses. Simplicity means how easy the program is to understand and write. A simple program is easier to work with and usually has fewer mistakes. Generality, we measure the range of inputs and special cases. Lastly, optimality is when there is no other algorithm can do better. Now, data in a program can be organized in different ways. We call these data structures. For examples, we have arrays, linked lists, stats, queues, and trees. Each structure stores data differently. For example, arrays store data in order, while linked lists are more flexible when adding or removing data. These structures affect how fast a program can work. In my opinion, an easy-to-read program is not always better than a complex program, but faster program. This is because both understanding and speed are important. As a developer, I prefer easy-to-read code because it is easier to understand, fix, and improve. But if a complex program is much faster, then it can also be useful. So it depends on the situation. So, to conclude, a good program is not just about being simple or fast. It depends on the problem. We need to balance both simplicity and efficiency.
Hello everyone, my name is AMIRATUL FARZANA. Today I will explain the brute force or exhaustive search method, how it works, an example of its application, and my opinion on its use in real-world delivery apps. What is brute force? Brute force, we check every possible solution, continues until the correct or best answer is found, guarantee the correct solution if one exists. Brute force is one of the simplest problem-solving methods. Instead of using shortcut, it checks every possible solution until the correct answer is found. How does it work? First, generate all possible solutions. Second, test each one. Third, check whether it is correct. Fourth, if not, continue. Next, stop when the correct answer is found. The algorithm systematically tests every possibility one by one. Because every option is checked, the correct solution is guaranteed if it exists. Next example, unlocking a 4-digit PIN. For example, if someone forgets a 4-digit PIN, brute force will try every possible combination until it finds the correct code. The same idea can be used to compare every possible delivery route and choose the shortest one. Would you prefer a perfect route that takes hours to calculate or a good enough route that calculates into seconds? My answer is I would choose the good enough route because more faster response for user, more practical in a real-world delivery service, save computing time and resources, customer value quick service over waiting for a perfect route. Brute force is simple and reliable because it guarantees the correct solution. However, for large real-world problem, Faster algorithms that provide near optimal solution are often the better choice.
Hi everyone, my name is HAZWANI binti AYOB with number matric 307124, and now I'll be presenting topic C, which is the split it up method, also known as divide and conquer. Before you look at the algorithm, imagine that you have a huge pile of papers that need to be organized. So trying to sort everything at once will take a lot of time and effort. Instead, you first divide the large pile into the two smaller piles. Then you keep dividing those piles into even smaller piles until each pile is small enough to organize easily. And finally, after each small pile is organized, you combine them back together to form a full organized stack. So this is exactly how the divide and conquer strategy works. It consists of three simple steps, which is divide, split a large problem into a smaller problem, conquer, solve each smaller problem separately, and combine, merge all the smaller solutions together to solve the original problem. So by breaking a large problem into smaller pieces, the algorithm becomes much more efficient and easier to solve. Alright, now let's look at the common example of divide and conquer, which is merge sort. Suppose we have an unsorted list of numbers 8, 3, 2, 9, 7, 1, 5, and 4. Instead of sorting all 8 numbers at once, merge sort first divide the list into two smaller halves. So the left side become 8, 3, 2, 9, and the right side becomes 7, 1, 5, 4. Next, each half is divided again and again until each group contains only one number. So at this stage, we stop dividing because a single number is already considered sorted. So now, we start the combine and merge process. Instead of simply putting the numbers back together, we compare the numbers and arrange them in ascending order while merging. For example, 8 and 3, it becomes 3 and 8 because 3 is smaller than 8. So similarly, 2 and 9 becomes 2 and 9. Next, these two sorted groups are merged again. So we compare the first number from each group. Between 3 and 2, we take 2 first. So that's how it works lah. And finally, we add the remaining 9. So the result will become 2, 3, 8, 9. The same process will happen on the right side until we get 1, 4, 5, 7. And finally, we merge the two sorted halves together to produce the final sorted list, which is 1, 2, 3, 4, 5, 7, 8, 9. So this example show how divide and conquer solve a large problem by breaking into smaller parts, and then we combined the sorted result. Now I would like to answer the opinion questions. So the question is, splitting a problem up and merging it back together makes the process faster, but it temporarily uses more computer memory. Do you think the speed boost is always worth the extra memory usage? So, in my opinion, the speed improvement is usually worth the extra memory usage because it allows the computer to solve large problems much faster. So modern computers generally have enough memories, so this is not even a major issue in most situations. However, if a computer has a very limited memory, using an algorithm that requires extra space may not be the best choice. In that case, a slower algorithm that uses less memory might be more suitable. Therefore, I believe that divide and conquer provide a good balance between speed and efficiency. But the best choice depends on the available memory and the type of problem that we are being solved. So in conclusion, divide and conquer is an efficient way to solve large problems by breaking them into smaller parts. So merge sort is a good example because it divides, sorts, and combines the data to produce the final result. So that's all from me for the topic C. Thank you very much.
Hello everyone, my name is WAFIAH binti BAHIZURKI. Now we are going through the decrease and conquer, which is most likely to be called as the string it method. Okay, decrease and conquer. It is actually really simple, which is instead of tackling a big problem all at once, we reduce it into a smaller version of the same problem, step by step, and until it's small enough to solve easily. And once we solve that small version, we extend that answer back to solve the original. So it works with three steps, which is reduce, solve, and extend. As you can see here, when we reduce, we shrink the problem into small instances. After that, we solve the smaller, simpler version. And after we solve that, we extend the solution to answer the original. Now, there are two ways this shrinking can happen. The first is decrease by constant, where we reduce the problem by one element each step. A classic example of this is topological sorting. The second type is decrease by constant factor, where we reduce by a fraction, usually half, each for each step. This one is much faster, and the example I'll be using today is Russian peasant multiplication. Okay, so let's look at the example. When we computing 20 times 26 but without doing a normal multiplication, here's how it works. We have two columns, which is n and m. We keep halving n and doubling m at each step. The rule is simple. If n is odd, we keep that row's m value. If n is even, we skip it. So, when we look at the table, when n is 5, which is odd, we keep 104. When n is 1, which is also odd, we keep 416. But the rest we skip it. Then we just add those kept value, which is 104 plus 416 equals to 520. And that's exactly 20 times 26. So, as you can see here, we have n at every step, shrinking the problem all the way down until n equals to 1. That's a decrease and conquer in action. Okay, so now let's look into the opinion question asked. Is it worth sorting your data first before searching, or should we just search through messy data directly? My answer is yes. It is worth the effort. And here is why. First, when the sorting cost is one time, which you sort once, but you can search that data many times after. So the upfront effort pays off in the long run. Second, searching becomes so much faster. Sorted data lets us jump straight to what we need. When, for example, we think of using a phone book versus digging through a random pile of papers. And third, there is actually a hardware level speed advantage. When we know that computers love halving and doubling because they use binary bit shifting, which is one of the fastest operation a CPU can do. That said, it always depends on context. If you're only searching for once, or your data changes constantly, it might not be worth sorting first. But for most real-world cases, sorting first is absolutely the smarter choices. And that's my part. Thank you.
Hi all, my name is THAPANIE, anak perempuan AIBAU, and my metric number is 307160. And today I will be presenting topic F, which is the immediate best choice method. also known as the greedy technique. You might wondering what is the greedy technique means. Well, a greedy technique is a problem-solving method that solves a problem step by step by always choosing the best option available at that moment. The idea is to make a decision that looks optimal right now without considering what might happen later. Because of this, greedy algorithms are usually very fast and simple to implement. There are three characteristics of greedy algorithm. First, the choice must be feasible, meaning it follows the rules of the problem. Second, it must be locally optimal, which means it gives the best immediate benefit at that step. Third, the decision is irrevocable, meaning once the choice is made, it cannot be changed later. These characteristics explain why greedy algorithms are efficient, but they do not always guarantee the best overall solution. To better understand the greedy technique, let's look at a simple example. Imagine that you are sitting for an exam and you have a limited time. Each question has a different marks and require different amount of time to finish it. A greedy approach would immediately choose the question with the highest mark first because it appears to give the biggest reward at that moment. This decision is considered as greedy because it satisfies all three greedy conditions. It is feasible because the question is available to be answered. It is locally optimal because it gives the highest mark immediately. And it is irrevocable because once time is spent answering the question, it cannot be unwind or recovered. However, this strategy may prevent the student from answering several smaller questions that might add up to give us highest total score. This shows how greedy algorithms prioritize local optimum over global optimum. Greedy algorithms are commonly used in real-world applications because they are fast and easy to implement. One of the examples is Prim algorithm, which finds a minimum spanning tree by repeatedly choosing the lowest cost edges to connect all nodes. This makes it useful for designing efficient networks such as communication or wiring systems. Another example is Dijkstra algorithm, which calculates the shortest path between nodes by always selecting the closest unrigid node. It is widely used in navigation system and routing protocol. Greedy techniques are also applied in Huffman coding for data compression, where the algorithm combines the least frequent character to reduce the storage size. Overall, greedy algorithms are preferred in situations where speed and efficiency are more important than finding a perfect global solution. Now, I will move on to the opinion question. These methods are incredibly fast but do not always give the perfect global solution. Would you trust this kind of method to manage your personal financial investment? Why or why not? Alright, so as a developer, I would not trust a purely greedy technique to manage my personal financial investment. Although greedy algorithms are very fast and efficient, they only focus on short-term gains and ignore the long-term consequences. For example, a greedy approach might invest all money into a single rapidly rising stock without considering the market volatilities, long-term risks, and diversification. Since greedy decisions are irrevocable, the algorithm cannot adjust when the market conditions change. Therefore, financial investment requires more comprehensive strategies such as dynamic programming, which consider both present and the future outcome. That's all from me. Thank you.